Ladies and gentlemen, this is Andrew Yarov. He is a key account manager for International Paint based out of Houston, Texas. He's focused on supporting fire protection business development in North America, as well as providing field technical support. Andrew has a background in fire protection, holding several positions over the years, including Q&A position with a large fireproofing applicator based in the Gulf Coast, as well as technical service representative for a coatings manufacturer. Andrew now has 9 years of experience in the coatings industry, is a member of AMP, and volunteers his time with the Houston Area Coating Society annual painters competition. Ladies and gentlemen, Andrew.
Thank you, Sam. So today our topic of discussion is going to be around fire protection, and we're going to ask the question and try to answer, is your passive fire protection fit for purpose? So when we ask that question, is your fire protection fit for purpose, there's a lot of factors that come into play when we're trying to answer that question. What's the service environment? What's the durability of the product you're using? And what's the constructability of the product as well? And how well will it benefit your schedule for new construction? So with service environment, is it going to be in an extremely cold or extremely hot, or will it be in an environment that experiences severe temperature swings? What's the microenvironment going to be like? So here we see cooling towers. That's a familiar sight in all the facilities. Fallout from cooling towers is a very common thing. Will your fire protection be exposed to constant moisture from a cooling tower? Where is the facility located? Is it offshore? Is it going to be adjacent to a saltwater environment? When it comes to constructability, how much of the material is getting done in shop, and how much of the material can you ship per truckload, and how quickly can you get it to your job site? All of these factors come into play when we're trying to figure out, is it fit for purpose? So we're not going to go through every item on this list, but there's a couple key factors I wanted to point out that help to answer that question. So for the purposes of this discussion, we're going to keep it generic. Product A will be high density concrete, product D will be lightweight cementitious, and product C will be your epoxy intumescent. So the first thing to point out is, what's the UL 1709 listing and thickness of each product? Well, high density concrete is a legacy product. It does not have a UL 1709 hydrocarbon pool fire listing. It's a legacy product, so the old tried and true method in the plants is 2 inches of concrete gives you 2 hours of fire resistance. Product D, the lightweight cementitious, you need 1.125 inches thickness in order to achieve a 2-hour rating. Product C, you only need 4/16ths of an inch in order to achieve a 2-hour rating. Now, why this is important is because through the life of the asset, there's going to be additions placed on that structure. More piping, more valves, more equipment. When you can afford more opportunity to squeeze more into that structure, that's a huge benefit for the owner. Next, I want to talk about the weight for the 2-hour rating. So product A is 26 to 28 pounds per square foot. It's pretty heavy. Product D is 5.2 pounds per square foot. Not too bad. Product C, the epoxy intumescent, is 2.2 pounds per square foot. Why does this matter? Because we all know that these structures are engineered with a structural weight limit factor. They are obviously given an extra allowance to accommodate those additions that we just talked about through the life of the asset. However, if we can keep the weight to a minimum on the structural steel and reduce the stress on that asset and on the structure itself, that's also a huge benefit for the long run with the owner, and adding more equipment to that structure and not overloading it. Next thing I want to talk about goes into the durability aspect. So Norsoc M501, that doesn't necessarily play into our side of the business on the downstream segment. That's a test standard that was designed for upstream North Sea offshore assets. So it's a very challenging test to pass for a coating. And what it's meant to do is to test the true durability of a coating's ability to survive in the most aggressive and harsh environments of the North Sea. As you can see, both product A and product D do not have a Norsoc listing, whereas product C does have that M501 listing, and it even passes without a top coat. So that just goes to prove durability between the three products. The maximum service temperature, that's an important thing as well. We all know that process equipment is extremely hot in these facilities. Both product A and product D cannot withstand anything above 185 Fahrenheit, whereas product C can go up to 250 F. Again, we're all about trying to make flexibility for owners here, so That is obviously a huge important factor for them. The next one to talk about is how much material is actually applied in the shop. Both product A and product D, you're doing about 80 to 85% of the material in the shop. That's not bad. With the epoxy intumescent, you're completing 95% of that steel in the shop before it even gets to your job site. That's a huge cost savings for an owner because the rate to apply fire protection in the field significantly surpasses the shop rate. So if you can do more in the shop, that will greatly increase the efficiency for your schedule and it will help manage cost. A few more things to cap on this slide. Full cure time. So again, that schedule is extremely important on new construction. Both product A and product D have 28 days to full hydration. So that's 28 days of waiting to get it out to site. Whereas product C is ready to go on a truck and get out to the job site in 24 to 36 hours. You can see how that can greatly impact your schedule, one versus the other product. Shipping costs, both product A and product D are fairly higher than product C, and that's for the simple fact of you can't stack as much of A and D on top of each other, and you also have to take into account road vibration, potholes, potential damage that can be incurred just on the flatbed on its way to the job site that you now have to repair once it gets to your job site. Whereas product C has the lowest cost because, speaking from experience, I've stacked 44,000 pounds of fireproof steel on a flatbed trailer and sent it to a job site. So we're maximizing that one truckload, and when it gets to that job site, it's getting there intact, still adhered to the steel. Now lastly, let's get to that life cycle cost, CUF potential. Both product A and product D have very high potential to propagate corrosion under fireproofing, CUF. That's because those products can act like a sponge. They do have the unfortunate factor that they do take on water. They have a higher water absorption than product C, which creates a more impermeable barrier layer protecting the structural steel, both in the sense that it's doing its job for fireproof, protecting it from fire, but it's also protecting it from moisture ingress. Water will always find the path of least resistance and will work its way behind the material and into the steel and create a CUF scenario. Maintenance cycle between the products. Product A, it's an every year maintenance cycle with the high density concrete. Lightweight cementitious, you're looking at it every 5 to 8 years, and then the epoxy intumescent is designed to be a 25-year system. So obviously you can see where the cost savings are there as far as allocating resources to constantly inspect the products and then having to pay for someone to come out and fix it. So you can see how there's a benefit breakdown between those three. So cost is the major driver in these projects. But we have to ask ourselves, how are we calculating that cost? Are we looking at it at the upfront during the project planning phase where we're just trying to save a few dollars in the initial investment? Or are we using a total life cycle analysis, which in my opinion is the proper way to quantify how much you're willing to spend on a specific product like your fire protection? Because if you look at the total life cycle cost between these three products, yes, product A and product D are much cheaper up front, but they are far more intensive on the maintenance side and require a lot more attention throughout the life cycle of the asset. Whereas product C has the long-term durability to last that 25 years. So let's talk a little bit about all three products. We'll start with the high density concrete. It's quite labor intensive in the shop to install. As you can see, they have to make a form. You've got to get the lath on there, pins, and then you've got to pour the forms. You have the hydration period. It's just a lot of steps that have to be accomplished when you're installing this in the shop. Obviously, when it gets out to the field, it looks great. That's a good finished product. But remember what we talked about, how much is done in the shop versus what's in the field? Look at the size of the block out that now has to be completed by guys up in a man lift in the line of fire, spending more time working at heights and having to affect, and again, that labor rate is exponentially more expensive when you're doing this in the field. So that's something to consider. Really, we could say the same thing for the lightweight cementitious. It looks great the first year coming out of the shop. You're going to have the big block outs to deal with again. It's quite labor intensive to install in the field. As you can see, they have to install the galvanized lath. They have to install the corner beads here. You have to smooth it out to give it that good aesthetic finish that the owners also want. It's got to be a functional product, and it also has to look good. That's something that owners always want. And then we get to the epoxy intumescent. Much smaller blockouts. That's about 95% of it being done in the shop. It's a much more condensed process when you're installing it in the field. As you can see here, this crew has installed or has sprayed on the first coat. They're installing the mesh. I bet you they could go to lunch, come back and put the second coat on after lunch and be done with that section. And of course, the bottom two photos show the finished product, and it's a great looking finished product as well. So, we talked about the cost is a major driver. There's always an elephant in that planning room. And that elephant, and everybody always says, you know, what problem? We're saving money up front on the construction, so what problems are we going to have? So what we see here is a highly corroded piece of steel, barely any fireproofing left on it, pitted out. The elephant has reared its head, and now that problem is starting to show itself, and now it's no longer a problem for the CapEx group. Now the operations team has to figure out how to preserve their asset and ensure that we don't get to this phase. So let's talk a little bit about some of these failures that we can typically see in the field. So this column right here is concrete products, high density concrete. The first photo is a vessel skirt operating above that 185 temperature mark. So what that does is dehydrate the concrete and creates the cracking, which eventually leads to disbondment and objects falling off. Now that's a hazard, that presents multiple hazards, because first and foremost, that's dangerous for our people to be walking in the facility and run the risk of something falling off a piece of fireproofed steel, hitting them in the head. And on top of that, ready to fall hazard, we also now have unprotected steel. So if there is a fire situation in that facility, our steel is now exposed to that hydrocarbon fire, which puts the entire asset in danger. The middle column here, we're looking at a lightweight cementitious product. Same thing. This lightweight cementitious product was installed on a process pipe operating above that 185 threshold, temperature threshold. You start seeing the dehydration, the cracks, moisture finds the path of least resistance. You now will get corrosion under fireproofing at some point, and it will lead to the same type of scenario. Disbondment and detachment from the steel. So again, dropped objects, unprotected steel. The last column is epoxy intumescent. So the first photo looks like it was some solvent entrapment that blistered up, and this is due to poor application and overcoating too quickly. You do have to allow the solvent to flash off before you put that second coat on. This created a blister because that solvent wants to escape out. So that blister continued to grow, and then eventually it damaged the coating. So now we have to go back and effect a repair. The photo below, you can see a stress crack right here. This scenario, it's an equipment pedestal. Now the applicator did not control the film thickness as they were applying it, and they applied it well above and beyond any tolerances that are recommended by the manufacturer. What this does is create an extreme stress on the coating, which leads to the cracking that you see. Again, it's the same type of failure mechanisms. You're going to start getting moisture behind this coating system, and eventually it will lead to a failure. Now we'll talk about properly selected PFP systems and how they perform. So on the left, we have an Arctic service environment, obviously by the 10-foot flare hanging off of this column, but we have giant icicles coming off of this. So 8 years later, in an aggressive Arctic service environment, you have an epoxy intumescent holding up and performing its job, both roles protecting the steel from a potential fire scenario as well as any potential damage from corrosion. On the right, we have a 24-year later photo of an offshore platform that was fireproofed. It was the structural support was fireproofed. Equipment was put into service. You'll notice a little bit of chalking and discoloration on the actual support itself, but that's just a cosmetic discoloration. That product is still performing as intended 24 years later in an extremely aggressive environment. So it goes to show that material selection really does matter, and it can save you a lot of headaches down the road. This is a really important point that I like to drive home. CapEx influences OpEx. So again, the capital group likes to rob Peter to pay Paul. They like to save up front by selecting a cheaper material that they view as a win, but then they turn this unit over once construction's done, and now operations is left holding the bag 5 years later trying to figure out what to do with all this failing fireproofing. So these two teams should talk way more than they do. So let's talk about solutions. Can I mix repair materials? Let's see what UL has to say about it. So per UL, the use of alternative PFP patch repair materials, which are not included in the design listing, shall not be used. So basically what that says is you have to use like for like material. If you have cementitious material in your facility and you need to effect a repair, unless you choose to fully strip off all that lightweight cementitious, you will have to go back and repair with the same material. That's just per the UL standard. That's how you have to follow the rules for that specific product. There are multiple products you can choose from. Again, we have the high density concrete, lightweight cementitious, the epoxy, and one that's not known as much is the precast panels. So those are essentially, they're just panels that are created with epoxy intumescent product, and they're able to be assembled on the structure, kind of like putting Legos together. And that will allow you to replace the failing fireproofing and box out an area that needs to be protected. It's a very quick and cost-effective means to repair damaged areas. The only place where we have a bit of a gray area where you can potentially mix repair materials, you'll notice down here it says high-density concrete and epoxy. So as we talked about in the beginning, high-density concrete does not have a UL listing. Therefore, they do not fall under the same rules as other UL products. So what that says there is a lot of manufacturers have taken it upon themselves to test their epoxy intumescent material in conjunction with a defective area on a piece of concrete to basically use the epoxy as a repair mortar to fix any damaged concrete areas. Now, at the end of the day, that's acceptable so long as the owner is okay with it, their underwriters are okay with it, and the owner's HSE team is okay with it. And then, of course, you want to check with your manufacturer's rep to ensure that that solution is good and it's able to be effected in the field with their product. This is one that I saw a lot when I was working in the field in tech service and as an applicator. Can I mix blockout materials? So that's saying you used product X in the shop. Now your schedule has gone to hell and you want to use product Y because it's faster to put it on the blockouts versus continuing with product X in the field. So what does UL have to say about this? Exact same thing as the previous slide. It's a no. You cannot mix and match different fireproofing products in the field when it comes to a blockout situation. Again, the only one that we have the gray area in is that high density concrete to epoxy for the reasons that I just talked about on the previous slide. But other than that, the stance from UL is you must use the same material on the blockouts as what you used in the shop. And that's my presentation. So I appreciate everybody's attendance, and I'll open it up for questions.
So a lot of the things that I've seen in my time is just lowering the amount of risk. So the more that you can do in a shop in a controlled environment and less inside of the gates, that's a huge selling factor for owners in the business. Are you guys seeing more and more owners switching to intumescent over cementitious, or is it still an uphill battle?
It's still an uphill battle. The SMEs are driving it though, because we're dealing with a lot of the SMEs at site, and they're very eager to make the push in the maintenance situation to demo the old failing products like your cementitious or concrete and reinstall with an epoxy intumescent. But from the capital group, again, that disconnect is real between CapEx and OpEx. They really need to talk more, because at the site level, they prefer to go towards epoxy intumescent so long as they can afford it. Again, it is a bigger upfront cost. But from the corporate level, I guess, they're always looking to save money on these massive multi-billion-dollar construction projects. So unfortunately, coatings is usually the one that can take a hit sometimes.
Has epoxy intumescent fireproofing been affected much by the supply chain issues?
100%, yes. It's a fight between all the manufacturers: International Paint, Carboline, Sherwin-Williams, PPG, Hempel. All of us are fighting for raw materials for tank linings, external coatings, fireproofing. It seems like the suppliers of the raw materials allocate to each manufacturer on a monthly basis. a specific raw, and then next month they won't give it to us, and they'll give it to our competitor. So it's been a very big challenge.
Are you seeing a push for concrete now because of that?
We're seeing a push for alternatives simply for that, for the fact of schedule.
Yeah.
We can only delay projects for so long before an owner has to continue moving forward with construction, and unfortunately, sometimes they have to make sacrifices, and sometimes they don't. They really do sometimes prefer using the epoxy, but they're left with no choice.
Yeah.
It's been a challenging 2 years, I will say, and we're hopeful that things will change, but we'll see.
Have you seen any sustainability requirements or changes in shift in demand?
I haven't seen it, but I don't want to say that. I don't want to say that that's a no. But I personally, it hasn't come across in any of my discussions.